In this video, we're going to be looking at the normal distribution. Now it's all about this bell-shaped curve here. And with this curve, what we're concerned with is the area underneath the curve. This area underneath the curve represents probability. Another thing you should notice is this curve does not touch the x-axis, that horizontal axis. It gets closer and closer to it, but it never touches. So you could think about this area underneath it as infinite. It goes on and on. But of course, we did say it represents probability. So we should know what it adds up to if we manage to add up all of that infinite area. And you should have said 1. That area adds up to 1. Because of course we said this area represents probability, and probabilities always add up to 1. Now we can't always use this distribution, so I'm going to talk to you about when we do use this distribution. So here I've got an example. On the x-axis I've got heights. Now which heights got the most likelihood? And remember, this area represents probability. So which heights got the most probability localized around it? And hopefully you should have said 170. That's where that peak is. And that 170 would be the mean height. So the mean is always there in the middle. So let's talk about when we can use it, because we can't always use a distribution. Now height, as you know, is a continuous variable. It can take any value in a given range. For example, you can have 170, 170.01, 170.00005, whatever value you think of, you can have that as a possible height in a given range, of course. And that's known as a continuous variable. And we can use normal distribution for continuous variables. We wouldn't be able to use it for discrete variables. Discrete variables is when the variable takes only certain values. For example, the number of pets you might have. You can either have 0, 1, 2, 3, 4, and you wouldn't be able to take any value. For example, you can't have 1.2 pets. That's a discrete variable. We cannot use normal distribution to describe discrete variables. We only use it to describe continuous variables, such as height. And like I said, this curve never touches that horizontal axis. So you can take any number. For example, I've only written up to 220 here, but it goes on and on. It can go up to 300 as well. But the area close to 300 will be very, very tiny. An area representing probability means the probability of being that value is really, really tiny. Looking at this curve, you could say the majority of heights is between 120 and 220. There is some possibility of being outside it, but very small areas because the curve is getting very close. But of course, there's always a probability because it never quite touches. So here I've got a different variable on the x-axis. I've got weight. And weight is of course also a continuous variable. And of course, you should also be able to say the mean is 75 for weights because the 75 is in the middle and of course has the highest likelihood because it's got the largest amount of area above it. Okay, so there is some notations you need to know about the normal distribution. So let's look at this notation now. So we start with x and then we have the squiggly line and that means distributed. So we're saying x is distributed and then we use the letter n. And that's for normally. So we're saying that variable x is distributed normally, and then we open a bracket. And the next thing we're going to put in is the mean. And I've written mu here. And if you don't know this letter yet, this Greek letter is often used to represent the mean. Then we put a comma, and next we put the variance, which is basically the standard deviation squared. And last we close the brackets. So this notation you need to know. Remember, it's x is distributed normally with the mean mu and the variance sigma squared. So inside the brackets we have the mean and the variance. Of course, in this case, the variable is not x. We've written the variable as w. And of course, we know the mean value. Looking at this graph, the mean value is 75. We always know the mean is right in the middle. And the variance is 10 squared, which means the standard deviation is 10. Remember, the variance is the standard deviation squared. Now, there's a few areas we need to memorize. So here, I've got the area which is one standard deviation above the mean. Remember, variance is 10 squared, so the standard deviation is 10. So the mean is 75. I've gone 10 above that, which is 85, and 10 below that, which is 65. So the area between one standard deviation below the mean and one standard deviation above the mean is represented here. And we need to know the area of that by heart. And this area is 0.68. So the area within one standard deviation either side of the mean is 0.68. And of course, you can also say the probability being within one standard deviation is 0.68. Now, this area can also be written like this. It's another notation. It's saying the probability of being between 65 and 85 equals 0.68. Because these values, 65 and 85, are one standard deviation below and one standard deviation above the mean. Now here we've gone 2 standard deviations above the mean and 2 standard deviations below the mean. Of course, 2 standard deviations is 20, one standard deviation being 10. So I've gone 20 above, all the way to 95, and 20 below, all the way to 55. And the area between these two values we should know by heart as well. So you can have a guess because you can see it's the majority of the area. And it's 0.95. This area is 0.95. So the probability of being within 2 standard deviations of the mean is 0.95. Another one you need to memorize. And in notation form, it could also be written like this. The probability of the weight being between 55 and 95 is 0.95. And this time, we've got 3 standard deviations above the mean. So 75 plus 3 standard deviations is 30, which takes us up to 105. And 3 standard deviations below the mean, which takes us all the way down to 45. So the area between 45 and 105 is another one you need to know by memory. Now this is the last one you need to know by memory, so it's not too many. And you can probably guess it's going to be very close to 1. It's 0.997. Now if you went 4 standard deviations above and 4 standard deviations below, you're going to get closer and closer to 1. But you'll never get perfectly 1. Because like I said, this curve never actually touches the axes. And the notation for this can be written like this. So get used to seeing that too. Okay, so here I've shaded some area. I want you to try to guess what this area would be. Okay, so all of the area underneath the curve adds up to 1. And you can see this is half of that area. So hopefully you said 0.5. And this can be represented like this. The probability of W being less than 75, the probability of having a weight less than 75 is 0.5. And that's because 75 is in the middle. So before we continue, you could just restart the video and watch back up to this point before we carry on, so you can memorize those numbers. I hope you found that video useful. Support us by liking, subscribing, and share this with your friends. And if you still got some more questions on anything, drop a post on our forum at examqa.com where you'll find your questions answered.